Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome to our tutorial and today we will discuss about anthropometry and Handel's model. Okay, let's move. Let's take a look this illustration. We know that bicycle doesn't match with the user's body size and it will make the man feel uncomfortably and difficult to ride or use the bicycle. And then from this bicycle, we know that the pedals and handlebars and other part must be adjusted to the dimension of the human body. And then from the bicycle, it can be taken for the example of application of handle design, such as handlebar parts which has a grip size and the material must be adjusted to make it easier for the user to control the direction of the bicycle. Okay, and then in this video, we will discuss about the first is the objectives of the tutorial, and then for the second is the input and the output of the tutorial, and the third is the main material, and the last is the case study. Okay, the objectives of these tutorials are first, you be able to understand the concept of the anthropometry and Handel's design. And then for the second, you are be able to know the interaction between human, machine, equipment, material, working environment, and the importance of Handel's design in the prevention of CTDS. And then for the third is you can understand and conduct anthropometry data collection. Next, you can understand the strength of the hand grip and its influence on the Handel's design. And then for the last is you are be able to design a workstation for the best or work equipment based on the anthropometric data and in accordance with the ergonomic guidelines for Handel's design. Next, for the input in these tutorials are first, same as previous tutorial, you should collecting data operators, demographic, and descriptive data. The demographic data consists of name, gender, age, and etc. It is important because it affects a person's anthropometry data. And the next is the anthropometric data. It means the dimension of the body that are measured for later design. And then for the output of these tutorials are first is the result of the calculation and allowance, and then the second is the dimension of the workstation, product, or work tool that you have, and then the third is the design and the recommendation of workstation, product, or tool based on the anthropometric data and the ergonomic guideline for Handel's design. Okay, there is some definition about the anthropometry and Handel's. For Handel's is a part of anthropometry because it relates to the measurement of the human body as well. So the Handel's it can be defined with the extension of hand function that are quite important in daily life, which in their use can cause injury or danger based on Johnson 1993. Then, for the anthropometry defined as the measurement of the human body from the Bridger 1995. And then for the anthropometry, it comes from another word, namely anthropos, which means human, and metron, which means measurement. Thus, anthropometry has a meaning as a measurement of the human body, like that. So, after that, maybe you wondering what is the correlation between anthropometry and Handel's design, like that. Yes, I hope from this slide you can get the answer from this explanation, and then So both of these aspects need to be considered in designing an ergonomic product because comfort, safety, and switchability of work tool size will affect the interaction between workers and tools used, which can impact on work safety. Like that. For handles is concerned with the strength endurance factor of the hand grip and the aim to design product based on the ergonomic guidelines for handles design. And then after that, for anthropometry aims to design product based on the dimension of human body. Okay. Let's move. Okay, these are some application of anthropometry and handle data. And then for the first is designing the work area, such as workstation, car interior, and etc. And then for the second is design of work equipment. And then for the third is consumptive products, like clothing, chair, and so on. Okay, there are three basic philosophies for a design used by ergonomics as anthropometric data to be applied. For the first is design for extreme, which means that for the design of the particular place or work environment, individual anthropometric data should be used, too high or too short, like that. And then for the second is design for average. For design for average, can be used to determine body size in general. The application of anthropometric data for product design and work facilities in public space, you can use the design for average because it has the 50 percentile like that. And then for design for range, the design can be changed in size so that can be flexible enough to be operated by everyone who has various body size. Okay. Okay guys, and then for the factors that can influence the size of the human dimension body. For the first is the age. The design for the equipment for the children will be different from the design of the equipment for adults. Okay, for the gender, by nature, adult male has the higher average height than the adult female body dimension. And then for the third is ethnicity. Most of Southeast Asian people are shorter than Europeans or Americans. And then for the next is social and nutrition level. It means high social level will have an impact on the fulfillment of the adequate and good nutrition. And then for the next is occupation. And then for the next is regional environment. Okay, there is some factors that influence the size of the human body dimension, but this is the specific spatial variability factors. For the first is disability, and then the next is pregnancy because the size of the glute for the pregnancy is different from the usual. And then for the next is climate. Okay, there are two dimensions that are used as a limitation in anthropometry. For the first is the space dimension. In designing workstation, the environment must be provide adequate access and circulation space used to determine the minimum acceptable dimension. Okay, because in this limitation, we use the larger percent in the population Okay, and then for the next is reach. For the reach dimension, use to determine the maximum dimension received by the object. So for this limitation, we use the smallest people in the population can be used to design. Okay. There is two parts. There's two kind of anthropometric measurement. For the first is static anthropometry. It means a measurement of all parts of the body in a standard and a static position, both in standing and sitting position. And then for the dynamic is a measurement of body parts in working conditions or the movement needed in a work. Okay, we will move to measurement steps. For the first is specify the user population. Okay. And then after that, determine the body dimension used. And then select the percentage of the population to be accommodated. And then after that, specify the percentile that used. And then give allowance if needed. And then use mock-up or simulator. Okay. We will move to the grip strength and endurance. What is the difference between strength and endurance? Maybe you guys wondering about it. In designing hand tools, the level of strength and endurance needs to be considered. For the strength, it means maximum force accepted by hand. And then for the endurance, the length of time to maintain strength, like that. And then there is some factors affected to the strength and endurance of the hand grip. For the first is age, okay, and then gender, vibration, wrist posture, grip type. There's a lot of types of grip, and then dominant hand. Okay, and there is glove size of grip span and diameter and surgery. Okay, for the explanation, maybe you can ask to the assistant on the class here, guys. And then for the next is hand tools design development. For the first is degree of slope. Okay, and then for the degree of slope, the 19-degree angle is formed by intersecting a straight line on the index finger with a line under the thumb pad. Okay, and then for design for a strong grip, we know that grip with entire hand. It means the grip fits in the palm so that strength can be optimized. And then for the maximum length of grip is 20.5 centimeters. Okay, and then for the maximum grip pressure is 100 Newton. So the maximum grip strength of the hand is generally that much. Okay, and then for the tool weight, maximum is 2.3 kilogram, preferably about 1.2 kilograms. Okay, we will move to ergonomic guidelines for hand tools design. Okay, for the first is avoid rigid design. To provide the contours of the tool according to the shape of a finger. And then for the second is provide workers with tools and machine control which can be operated most effectively with natural body parts, posture, and low force. And then for the next is avoid tool handles with sharp corners. Of course, it will be dangerous. Okay, And then for the fourth is the tool handle surface must be compressible, non-conductive, and smooth. And then for the fifth is tool handles should be fit with the hand. And then for the sixth is can be used by either hand, so for the left or the right-handed. Okay, for the seventh is choose or design tools that can be used effectively by both men or women. And then for the eighth is choose or design special purpose tools for specific tasks. And then for the next is the angles of the grip for arm and tool to minimize deviation. And then for the 10 is consider provisions for tool safety. And then for the last is provide vibration dampening for vibrating hand tool. Okay. This is the hand grip recommendation for hand tool design based on the degree of slope. Like that, you can see on the picture on your screen. And then for the anthropometric measurement equipment, there is flexible curve, anthropometric chair, and anthropometer. Okay, we will move to the anthropometric data processing. You should do the normality test. First, the normality test is a test conducted with the aim of assessing the distribution of your data or variables, whether the data distribution is normally distributed or not, like that. And then for the hypothesis, for H0 samples are normally distributed, and then for the other side, for H1, samples are not normally distributed. And then for the significance level is 0.05. Okay, so you can read the signification on Kolmogorov-Smirnov column like this. And then after that, for the percentile is the value of an anthropometric dimension that represents the percentage of the population that has a certain dimension or lower dimension. Okay. For percentile calculation, if you have tests for normality, you just need to calculate with according to the existing formula like on your screen. Look for the average of each dimension, and then after that the standard deviation, the same using the ZX table. Okay, and then we can know the Z score with the ZX table. And then in general, the percentiles are used are 5th percentile and 50 percentile and 95 percentile. For P5 and P95, you can just adjust the plus and the minus. Okay, for the P50, it is just if average value. Okay, for the allowance factor is given for each measure of the body dimension in the product design or workstation design. Okay, the allowance is an item attached to the worker's body which can affect the design. For example, the width of the door, so it is should be used the allowance to give the comfortability to the users. Yeah. And then thank you for your attention, and I hope what I give to you will give your understood with this tutorial material, and see you on your class tutorial. Please take note that what material that you confused about, and please ask this your question to your assistant on your tutorial class. Wassalamualaikum warahmatullahi wabarakatuh.